In this lesson, we will graph a hyperbola centered at the origin. Notice that the function for a hyperbola, or the equation for a hyperbola, is very similar to that of an ellipse. We have now the minus sign in between instead, and the other major difference is that the a value is always the first value. So before it was always the larger value, now it's always the value underneath the first term. So whether x comes first or y comes first, the a value is underneath that. Another major difference is now we have these transverse axes that are asymptotes, and they will help us in determining the shape of our hyperbola. So again, here's a table for you to reference. We'll talk about all of this as we go through these examples. So in our first example, I have y squared over 16 minus x squared over 20 equals 1. Again, this is my a squared value and this is my b squared value. So a squared is 16, even though a is smaller than b. That's different because it's a hyperbola. B squared is 20. The square root of 16, of course, is 4. And the square root of 20, the exact answer is 2 radical 5, but it's approximately 4.5. So these are the values that we're dealing with moving forward. Again, we know that the center is going to be at 0, 0, because I told you it would be centered at the origin. In addition, we can see there's nothing that's being added or subtracted to my x or y values. The foci, we know that we need our c value for that. And so to find the c value, we're now using c squared equals a squared plus b squared. So on my last one, I was subtracting a squared minus b squared. Because it's a hyperbola, we add. So in this case, c squared is 16 plus 20, which is 36, which means c is 6. In order to find the foci, the vertices, the equations of the asymptotes, I need my a, my b, my c, etc. Now I know because the y comes first, that instead of having a hyperbola that looks like this, I'm going to have a hyperbola that looks like this, which means the foci are going to be up and down from wherever the center is. So let's go ahead and graph our center, which is at 0, 0. And to find the vertices, remember the vertices would be above and below this. So to find the vertices, I'm taking 0, 0, and I'm going to end up adding the a value of 4, and I'm going to add it to the y values because it's below the y. So 0, 0 plus 4, and 0, 0 minus 4. So that's got 0, 4, and 0, negative 4. So 0, 4, 0, negative 4. These are my vertices. The hyperbola will actually touch these points. The equations of the asymptotes I'll get to in a little bit. They didn't ask us for the other endpoints, but I am going to go ahead and use my my center of 0, 0, and I'm going to use my 2 radical 5, and I'm going to end up adding and subtracting that from, again, the x value. So this would be 2 radical 5, sorry, don't need that comma there, 2 radical 5, comma 0, and negative 2 radical 5, comma 0. So about 4.5 and negative 4.5. And again, the reason I need those is because now I'm going to make my little imaginary box. Oops, went too far. My little imaginary box. And the whole purpose of that box is to help me to write or to draw in the asymptotes. So the asymptotes would go from essentially the corners through the center. And some people prefer to actually, do the equation of the asymptotes first and then plot them that way. I like to do using the box since I already have to do the box anyway. The equations of the asymptotes, because the y value comes first, is a is plus or minus A over B. So A is 4, and B is 2 radical 5. And again, it's going to be plus or minus. 4 and 2 reduce, so 2 over radical 5. But remember, we can't have a radical as a denominator, so I have to multiply by radical 5 on top and bottom. So my equation is 2 radical 5 over 5 and negative 2 radical 5 over 5. Those are the equations of the asymptotes. Now I've already plotted those, so I don't have to worry. Oh, I forgot the x's. Goodness gracious. An x on all of these, of course. So I've already graphed those, so I don't need to graph them now. So I have the equations of the asymptotes. I have my vertices here and here. The foci I have not found yet, so the foci are using my c value. Again, so the foci would be adding or subtracting c to the y value of the center. So that would be 0, 6 and 0, negative 6. Both here and here. And the last thing I need to do, of course, is to graph it. So to graph it, I have to go through this point, and I'm using these asymptotes that I've drawn as sort of guidelines. So it's going to come and touch this, and then turn around and go the other direction. And then, of course, on the opposite side as well. Just like that. So that is my hyperbola. This one doesn't quite look like a hyperbola, but again, just as we did before when we completed the square, if I take everything divided by 64, that's now going to give me x squared over 4 minus y squared over 16 equals 1. And now it does look like the equation of a hyperbola. So just as we did before, we're going to find our a value. So a squared is 4, b squared is 16, so a is 2, b is 4. Find your c value, which is 4 plus 16, so 20, so c is radical 20, or 2 radical 5. And I'm going to go ahead and plot the a and the b values. So again, 2 on the x, and those are actually my vertices. So my vertices are negative 2, 0, and 2, 0. I'm going to go ahead and go 4 in each direction to help me to draw in the box. And then I'm going to go through the center and the corners to draw in my asymptotes. So I've got vertices here and here. Remember, that means that my hyperbola will actually touch at that point. I do need to find, I know the center is 0, 0. I've found the vertices. The foci uses that c value. And again, we're going to be adding and subtracting that from the x value of the center. So that's 2 radical 5, 0, and negative 2 radical 5, 0. It's about 4.5. So I'm going to go 4.5 in this direction and 4.5 in this direction. And then, of course, I'm going to draw in using the asymptotes and the vertex as a guide to draw my hyperbola. Here's one for you to try on your own. So try this question, then press play to check your work. So again, I'm looking at an a squared value of 9 and a b squared value of 25, which means a is 3 and b is 5. If you want, you can go ahead and start plotting those points. Again, the a would go on the x-axis, so I'm going 3 units here. I'm going 5 units here. And that's how I'm drawing in the box. Do a better job than me on that. The center, of course, is 0, 0, so when I'm drawing in my asymptotes, that's how I'm drawing them, is going through the center. Much easier to do when you have a ruler and a piece of paper in front of you. If they wanted the equation of those, because the x comes first, it would be plus or minus b over a x. So in this case, that would be 5/3 x and negative 5/3 x. Those are equations. So if I needed to, I could use up 5/3 or down 5/3 to find the points that those go through. So we know the center is 0, 0. We have the vertices, which are -3, 0 and 3, 0. And then of course we need the foci, and the foci uses the c value. So c squared equals a squared plus b squared. So c squared equals 34. So c is the square root of 34, which is approximately 5.8. So about 5.8. So again, that means from my center, I'm going to go 5.8 in each direction. If I'm telling you what those points are, it's negative radical 34 comma 0 and positive, oh goodness, positive radical 34 comma 0. Those are those 2 points. And then all I have to do is use my asymptotes and my vertices to draw in my hyperbola. Just pretend I hit that point. And it looks something like that. Again, because the x came first, that's how I knew it was going to go this way rather than this way. If the y comes first, it's up and down rather than horizontal.